Hello everyone, and welcome to this video where I'll be taking you through a question on the objective: determine table values to use for drawing parametric curves by plotting points. So in this video, I'm going to be going through a question that you may come across when working on Knewton Alta assignments. So you're going to see here, let me show you. This is at Knewton.com. This is the Knewton Alta online homework system. And I'm in an objective called, graph parametric equations. And the title of the video, determine table values to use for drawing parametric curves by plotting points. And I'm just showing you, there's a whole list of examples of questions. I'm just going to go over one of them, and other ones that you'll see in this particular objective are similar to this one. So if you can follow along with my doing this particular question, other ones shouldn't be that much more difficult to figure out. And as I say with most videos, before I work on it, before you watch me do it, pause the video and try to work it out yourself first, and then come back and do it yourself and see how you do. All right, come back and watch me do it and compare your work to mine and see how you do. Okay. So the one question I want to go over is this one here. All right, I'm going to be going over the first one, or one that's most typical of the objective for each objective. So here we're asked to fill in the table of values that can be used to sketch the curve described by the parametric equations x of t equals 5t minus 10 and y of t equals 3t plus 2, where t falls between -2 and 2 inclusively. And when you're working on this in Knewton Alta, you see these 1 through 6 here. You're going to be asked to fill in the blanks, numbers 1 through 6, for the particular table given. So you see in this table a value of t. T is the independent variable. It's its own column here. And you got values -2 to 2, where they just keep increasing by 1. The value of x of t, the value of y of t for each of these 5 values of t. So parametric equations are equations that, here we're in 2 dimensions. We're going to be on the xy plane, right? There is an x equation and a y equation where x and y both depend on t. So they would call t the independent variable for both of these. They would call t a parameter, and x and y, the x coordinate of your position on the xy plane and the y coordinate of your position on the xy plane, both depend on this parameter t, right? So for each value of t, you're going to be at a different location on the xy plane, and I'll show you that when we're drawing this stuff. Okay. So first I'll do it on paper, and then I'll show you at a graphing calculator website. The graphing calculator websites I use will either be desmos.com or geogebra.org. So we're given our equations, x of t is 5t minus 10, and then y of t is 3t plus 2, right? So this is a simpler one because, they're both linear functions of t. But that won't always be the case. Just understand that you might get other kinds of functions of t. And the parameter may not even be called t. All right, so for t So again, I'm filling in this table. There is the t column. And then, for each value of t, there is a corresponding value of x and a corresponding value of y. And they're just going from -2 to +2 in this column here in the exercise. All right, so very simply, you're just, plugging in these values of t to get the corresponding values of x and y. So first row here, what's x when t is -2, right? So what's x of -2? Replace t with -2. Be 5 times -2 minus 10, and that'd be -10 minus 10, -20. So we have -20 for the x coordinate. Right, again, -10 minus 10. And then the value of y at -2 for the y coordinate of my location. And I go to my y rule here, y function, and replace t with -2, right? So it's 3 times -2, right? Replacing t, and then plus 2. This is -6 plus 2, which is -4. All right, now this was already given in the table and the exercise, but I'm just going to fill them all in myself. You were asked to fill in, this part, the -20. And then, I know it's not part of the exercise, but this will come up in the future, so might as well talk about it now. We can also graph our locations on the xy plane, right? We have an x equation, a y equation. So I'm going to go over here and make a little xy plane. No, I don't. If you have graph paper, that might be nicer. And then when the value of the parameter, this parameter called t, is -2, we're at this location. When x, now this won't be perfect, I'll go to a calculator later. X will be -20 when t is -2, and y will be, -4. So we're at this location. I'll plot the point. Here's -20, comma, -4. And this sometimes they'll also label with the value of the parameter. So this is when t equals -2 right here. Okay, and I'll come back to this. Right? I'll keep bringing this xy plane back and we'll add to it. All right, so next row, when t equals -1. All right, the value of x at -1 is 5 times -1 minus 10. All right, going into my x rule, placing t with -1. That's -5 minus 10, -15. All right, so I got -15 for the x coordinate. And the y coordinate, right, the value of y at -1 is 3 times -1 plus 2, right? Replace t with -1. So that's -3 plus 2, -1. Okay, so when the value of t is -1, the location we're at on the xy plane has an x coordinate of -15 and a y coordinate of -1, which I'll do here. All right, so again, I'm going to do here is -15, -10, -5. All right, let's do this. And then -3, -2, -1. All right, we'll do that. So we're here at this location, -15 for x, -1 for y. Maybe label it, all right, -15, comma, -1. Also, possibly it would be nice to let the person reading know what the value of the parameter is there, right? This is when t equals -1 in a different color. Now, I wouldn't connect these with a straight line just yet. I mean, you might be able to tell based on the fact that both parametric equations here are linear functions that this will be a straight line picture. Just because you have 2 points up doesn't mean you're going to have a straight line between them. All right, here they will be but in other examples with other kinds of functions, they may not. So let's just put up some more points and see if we can see more of a straight line pattern forming here. Okay, so that was when the value of the parameter was -1. Now when the value of t is 0, and going into my x and y rules, the value of x at 0 is 5 times 0 minus 10, which is 0 minus 10, which is -10, right? So that's going to go here. And when t is 0, the value of y at 0 is 3 times 0 plus 2, which is 0 plus 2, which is 2. Okay, so we're at the point -10 for x, +2 for y. And once again, I'll draw a picture. So -10 for x, and then 0, 1, +2 for y. We're at this location here. Sorry about the overlap there, -10, comma 2. And this is the point when t equals 0. So we are seeing a kind of a straight line pattern forming here, right? These all seem based on my hand. I mean, it is a hand drawing, so it's not exactly perfect. We'll go to a calculator, see a better picture, but we're seeing a kind of a straight line pattern forming here. And as the value of the parameter increases, or as the value of t increases, the orientation of the curve is, this way. You're going to have to put direction to these things as well. We'll get there in a second. All right. Then when the value of t is 1, the value of x when t is 1 is, 5 times 1 minus 10. 5 minus 10 is -5, right? So -5 for that. And the value of y when t is 1, right? The value of y at 1 is 3 times 1 plus 2, which is +5. Right? So -5 for x, +5 for y. I'll label that once more, draw a little point. So -5 for x, +5 for y. We're at this location on the xy plane, -5, comma 5. And this is when t equals, 1. Still following a kind of a nice straight line pattern, it looks like. And then finally, for this problem, when t equals 2, right, the value of x, at the bottom here, the value of x at 2 is 5 times 2 minus 10, which is, 10 minus 10 or 0. And the value of y at 2 is 3 times 2 plus 2, which is 6 plus 2, which is 8. So 0 for the x coordinate at this value of t, at t, 8 for the y coordinate at this value of t, and we'll be on the y-axis, right? 0 for the x, you're on the y-axis. And let's plot that one more. 1, 2, 3, up. So there's 0, 8. All right, 0 for the x, 8 for the y. And this is when t equals +2. And based on the pattern formed here, right, like with most graphs, find a pattern, and then you can kind of fill the rest in. So it looks like what's happening as the value of t increases, our location is going from here to there, right? And as I said a second ago, usually they'll put orientation marks, direction marks on parametric curves, indicating where you are, where the curve is going as the value of the parameter increases, right? So as our t increases, we're going this way, right? Here's some little arrows pointing the direction that the curve is going in. All right. All right, so the blanks that we'd fill in here would be -20, -1, -10, 2, 5, and 0. All right, if you look back at the problem, all right, those fill in the blanks, and you can see -20, -1, -10, 2, 5, and 0, as I said out loud a second ago. All right, so that's all that was asked for there, and for problems in this particular objective, you're just filling in the blanks. Now let me show you on this is desmos.com, desmos.com, a nice free online graphing calculator site. Now, if you want to put in parametric equations in 2 dimensions here, you got to put it in as you would a point in order to pair. So you see I put a left parentheses, and then for the x coordinate 5t minus 10, comma, and then for the y coordinate 3t plus 2. And then you'll see underneath this a little range of t shows up. You might see a little piece of green graph over here, a green segment. Remember, our t values in the table range from -2 to +2. All right, let me show you what that looks like. And zoom out here. And you see the picture of this little green line, as well as green segment. See up here, that is clearly at the point 0.8. And down here, this is, -20, -4. Now, if you'd like to see the orientation, all right, I'm going to do this again with a different letter. All right, we'll keep the segment up. I'll keep the original segment up. I'm going to put another ordered pair, but with just a different letter and a different parameter. Call it, instead of t, I'll call it s. So 5s minus 10 for the x coordinate, 3s plus 2 for the y coordinate, and then it'll say, add a slider for s here. And then you can see what point you're at for different values of the parameter, right? When s was 1, the same s is acting like t. I just changed the letter, that's all. So when t was 1, we're at the point -5,5, and that was in our table. When t is 2, you're at the point 0.8. When t is -2. See how you're at the point -20, -4, as we said in the table. And then if I hit play, you can see as the value of the parameter increases what direction the point is moving in, right? Maybe I'll slow this down a bit. Let's slow this down a tad. Maybe change it from -2 to 2 even. Have it go by ones or something. Or let's have it go by hundredths, just so you can actually see the motion. And then hit play again. You see it starts off there at -20, -4. Hit play. As the value of the parameter increases, you can see for sure, when I slowed it down a bit, the movement of the point on this curve. All right, so play around with it, right? Desmos.com, you can play around with parametric equations pretty nicely. And that's it for that. Okay, so just wanted to do again one problem for each objective here, and hopefully seeing that one problem in an objective will help you with other problems that you see in that same objective when you're going through the Knewton Alta assignments. And thank you very much for watching.